Hello guys, welcome to the channel. Today we will be solving this LeetCode problem of the day. Today is 27th Jan 2026. So let's read the problem and let's try to solve it. So we are given an undirected weighted graph with n nodes labeled from 0 to n minus 1. There are ages. Each age has a weight and it's a directed graph. So yeah, there can be cycles in it. And these are some of the observations. And now we have to perform exactly one operation for each node that we can, reverse and incoming age, right? Uh, as you can see, we can activate one of its incoming edge and reverse it. So the incoming edge becomes the outgoing one, and then we want to check, but and we can traverse that reversed edge, but the cost will be 2.2 times the current weight. I mean weight of the normal edge. And we have to return the minimum total cost required to reach from node 0 to n minus 1. Okay, so what we are given, we have a directed graph, right? So graph looks something like this. Let's say to we may have four, then here, right? We'll have some weights for each age. Okay, so let me do one thing. This is reversed, and also this is reversed. Okay, let it be. Now let's give some weights. Let's say this is 90. This is, let's say, 6 only. This is, let me do one. Now, let's say whatever it is, this is 3, let's say, and 1 and 1, let's say. So, as you can see, we have only, I mean, if you observe, I will write the observations before, solving the problem. First thing, there may be cycles. And the second thing, any age for a node can be reversed. And if you see, this statement is very, very important. Like this is applicable for a single node. It is not applicable for the whole graph. Okay. So like, let's say if I reverse this edge, okay, and if I reverse it, I can reverse this edge too. Okay. Similarly, for 3, if I reverse this edge, I can reverse the this edge as well. But let's say for 3, if I reverse this edge, I cannot reverse this edge. Okay. So for the same node, we cannot reverse more than one. For the same node, we cannot reverse more edges greater than one edges. Now this gives us an idea, like we have to find the minimum path, right? So it should come to your mind, right? There is a minimum path. You should either think of Dijkstra algorithm or BFS. Okay? But as the graph is weighted, so you should only think about Dijkstra's first. Okay. So what in Dijkstra we what we want to do? We want to find out the minimum distance, right? To reach from 0th node to 4th node in this case. Okay. If you see, if you observe, the optimal operation will be to reverse this, and it will cost 12, right? It will cost only 12 units. Otherwise, it will cost 90 plus 3 plus 1 plus 1. Okay, so that will not be efficient. So how to implement that, right? So here comes the, you should know about Dijkstra's algorithm. It's how its dynamics work. So if you okay, let's say if we reverse this edge, okay, let's say if we reverse this edge, let's talk about 3 first, okay. Let's say if we reverse this edge, okay, what will happen? We will add 2 times the cost of previous edge and then traverse through it and then go to 2. But the thing is that we will never visit 3 again, once again, because Dijkstra works like that, right? But if you visit a node, why would you go back once again to that node, right? It will always be, heavy in cost as compared to the normal traversal. So, which says that we can try reversing all of the edges. We can try reversing all the edges. So for each node, what we will do, so first of all, we will push our zero node. Its distance will be 0, and then the distance and yeah, nothing else. This will be the distance, and I mean it will be the cost, and this will be the node up till now. Okay, so first of all, we will push this, and then let me just double. Once we have, as I said, we will have cost, and in the priority queue, we will first push our zeroth node and its distance. So find it like this will be the, this will be the node, and this will be the the distance or the cost required to reach up till that node, right? So what we will pop that element. So first we will have, so in the pq.top, we will in the zeroth part. So pq.top will be an array of 2. It's an array of integer, comma 2. Okay. So we can, in this part we have a distance, and in this part we have our node. So this is our distance. This is our node. This is our current node. Now we will, for this node, we will traverse through its edges. Okay, and then in normal Dijkstra, what we do is just compare the new distance compare the new distance with the I mean distance vector. I mean this maintains the minimum distance required to reach up to that node. Initially, it is initialized to int max, or I mean the infinity. Then if it is strictly less than the distance of that new node, the neighbor node, right? Then we will update this new distance. This distance of neighbor, and eventually we will reach up to our solution. So let me explain it through implementation, as it will be more helpful. Okay, so first of all, we will take the adjacency list. We will make the adjacency list first. And as you know, we can reverse the edges, right? So we would like to take a reverse ADJ. Okay, as there are n nodes, it will be of n size only. So we will now traverse through edges, and now if you see, our u is it of 0, our v is it of 1, and our w is it of 2. Now what we will do? So in the normal adjacency list, we will simply push back So as you can see, this will be array of two, array of int comma two. So basically, uh, it will contain two elements for. So let me write an example. So let's say if there is a node 0, uh, it will contain something like this. It will be vector of array of int comma 2, right? So it will be let's say from 0, I can reach up to node 1 with weight 2. Let's say for 2 I can reach with 8 weight 1. Okay, and similarly other things follow the same thing. Okay, this will be the adjacency list. Okay, here don't get confused, like it's an array of integer and its size will be 2. So every array size will be 2 in this vector. Okay, so that's what I'm doing. The adj of in the u, in the list of u, I will push back my v and my w. Okay, it is just what I'm doing. And in the reverse edge, right? In the reverse adj, what we want to do, we want to reverse it, right? So it will be now from v to u. Okay, from v to u, what will be the cost now? It will be 2 times w, right? That's what it's given, right? Now what we want to do is we want to create an we want to start the Dijkstra. Okay, so what is needed? We need a priority queue in that. Okay, so what will be the elements? I mean, what will be a single element in our priority queue? So first will be our cost or test. Let's say it's cost, and the other will be our node. Okay, so that why the cost is taken first? Because the priority queue will be sorted based on the first element, and that is what we want to do. It should be cost because we want to find the minimum one, right? Minimum cost will be explored first. Okay, so of course it will be let me write something like that. This is what we do to define a priority queue with in sorted order, right? In the ascending order, right? So instead of int, we will use array of int comma 2. We do something like this. We want to use array of int comma 2 because it will contain two elements, right? This will just replace it with this. Now what we want to do, first we want to just push our cost and the node. We should start from 0, right? We want to travel from 0 to n minus 1. So that's why I have pushed 0, that is the cost, and 0, the second 0 is for the node, okay, 0th node. Now we want to create a distance vector as well, which will keep track of distance, right? So it will be for n nodes initialized with int max because our distance cannot be int max within this constraints. Okay, what can we do now is initially distance of 0 will be 0. Okay, now what what can we do, right? We will run a loop while my priority queue is not empty. We will take the current element, I mean the best element in the queue. We will pop that. Our cost is now pq dot I mean it will be current of 0 as as it is an array. I can directly access like it's current of 0, and for the node I can access like this current of 1. This is what I had mentioned in the line number 16, right? Okay, now what we want to do, we want to traverse. Now there are two options: either uh, reverse one of the edges and traverse it, or traverse the other nodes normally. Okay, so for each node we can have the reverse edges as well, right? So we want to figure out like uh, we will try every possible, I mean, reverse stage and every normal age as well, because we don't care about like if for each node, there must be a single element, I mean, single edge to be reversed, because that is the definition of extra, right? It will never happen because we will never reach out to the same node once again, and that will help us to track distances. So what we want to know, so if there should be a base case, if my node reaches to n minus 1, I should immediately return the cost. That will be the most, I mean, short, that will be the minimum answer. Okay. Now what we want to do is just, repeat. Now we want to, there are two options, right? Let's traverse normal edges. What we want to do, simple, we run a for loop, EDG of node. This is the normal adjacency list, okay? This is not the reverse adjacency list that we saw. Okay. So in the normal list, uh, my neighbor is in IT of 0 and my weight is in IT of 1. That is what I have pushed in there, right? It's V and W. V is the node, V is the neighbor node, and it is the weight. And the second element is the weight. Now, our new distance, our new cost will be equals the current cost plus the new weight. Now, if my new cost, if it is strictly less than uh, which node do we reach after this, right? So it will be the neighbor node, right? So I will check with the neighbor node. If it is strictly less than the neighbor distance of neighbor node, I will immediately update the neighbor node distance, like this is the best one possible, and I will push that neighbor node, and our cost will be the new cost, and the node will be the neighbor node, right? Priority queue. Okay, this is part one, and in the part two, I will traverse river stages. Okay, so let's see. Now, mind it like I'm taking this adjacency list is rep ADJ, not ADJ. Okay, now our neighbor will be ID of 0. It will be same as the previous one, and our new cost will be same. But as we have pushed 2 times W in it, so we don't want to, think upon changing the weight. Okay. So the same thing will continue if my distance of neighbor is greater than, strictly greater than new cost. Then my distance of will be new cost. I can push new cost from a neighbor. Okay. And finally, if I don't find any answer, right, I can return -1 because I'm returning answer over here. Let's try to run it. Happens, but it's over here. Okay. And you can see got accepted. Let's try to submit it, and it got submitted. Yeah, that's all for this. Thank you so much for watching.